This is the first of a few videos having to do with factoring trinomials. In this first video, we're looking at how to factor trinomials of the form ax squared plus bx plus c, where a is 1. A very common question related to trinomials of this form is that they be factored completely. If possible. Sometimes it's not possible. But what does factor completely mean? It just means, can you rewrite a trinomial as a product of things rather than as a sum or difference of things? In order to factor trinomials, it's common to use what's called the AC method, which means we multiply the coefficient of the squared term to the constant term. And then see if there are two numbers that multiply to give you that product and that also add up to the middle coefficient, the coefficient of the middle term, right? It's not easy to describe the method, but let's look at a few examples and hopefully it become clear. All right, let's look at number 1 here. It says factor completely if possible. All right, when you see this question, my suggested thought process for this type of question is to always first ask, what is the GCF, or is there a GCF? GCF meaning greatest common factor. And GCF means, is there a number that's common in each term? Some number other than 1 that's common in each of these terms. And in this case, we see there's nothing in common in each of these terms. All right, if there was something in common, we would factor that out first before trying to factor. All right, so next, let's go ahead and apply the AC method. All right, so we see that the coefficient of the square term is 1. If there's no number there, it's understood to be 1. So A corresponds to 1, C corresponds to the 40. So when I multiply 1 times 40, as in the AC method, I get 40. So the question is, are there any two numbers that multiply to give 40 and then add up to give the middle coefficient, which is 13? Are there any two numbers that multiply to give 40 and add up to give 13? Now, you can try 10 times 4 does give 40, but 10 plus 4 does not add up to 13. So we see that 10 and 4 will not work. And we just got to keep trying until we can find out if there are two numbers that will work. Now, 8 and 5 are two numbers that do work, right? And there may be one, there are two numbers that work, it will be unique. In other words, 8 and 5 are the only two numbers that will multiply to give 40 and that will add up to give 13, right? So now that we've found the two factors that satisfy the condition, there's two ways that we could factor this, complete this factorization. One way is a shortcut way. The shortcut way means it only works when the coefficient is 1 here, when there's a 1 here. So sometime it will not work, all right? But being that the coefficient of the squared term here is 1, we can take the shortcut approach. So the shortcut approach is just to write x plus 8 and x plus 5, and that completes the problem. All right, so this trinomial factors and becomes this here using the shortcut approach. Now, if we use the long approach, we would rewrite the first term, right? This is what I'm calling the first term. We would rewrite the last term. Give yourself plenty of space. And then we replace the middle here by the two factors that we found that satisfy that AC condition. And beside those factors, I put an X. Now, it doesn't really matter the order in which I write these two middle factors. I could have put the 5x here and the 8x here, right? It really doesn't matter. You'll still get the same result, right? Okay, so now that we've written it out like this, we're going to factor from the first two terms and factor from the last two terms, right? I don't suggest putting parentheses there around it. That is really a common mistake that people make. They put parentheses around these two and around these two, and you can fall into an error that way, all right? So instead of putting parentheses around, I just underline, to keep things in order, all right? So I'm factoring from these first two here. What can factor out of the first two terms? They both have x, so I'll factor out x from that. Now, when I take x out of x squared, I'm left with x, right? And you can see that if I multiply x and x, I get x squared. And then plus 8. And you can see that if I multiply x and x, I get x squared. If I multiply x plus 8, I get 8x, right? And then I look at the next two terms, and I see that 5 is common in both of those terms. So I factor out a plus 5, and it's important to put the operation here. So if you're factoring out a negative 5, you would put negative 5 here. A common mistake is that people sometimes put nothing there, right? So make sure you put the operation here, whether it be plus or minus, right? When I take positive 5 out and then put the parenthesis, after I take 5 out of these two terms, I'm left with x plus 8. Now, if you're not sure if it's true, go ahead and multiply back and see if you get back to what you started with. All right? And then let's continue further. We're not quite done. So now that we've got x plus 8 in both of these terms here, we're going to factor that out. Right? When you factor x plus 8 out of this first term, you're left with x. When you factor x plus 8 out of this term here, you're left with 5. All right, so whether you take the long way or whether you take the shortcut way, you still come to the same final result. And the shortcut way only works when the leading coefficient is 1. If the leading coefficient is not 1, and we'll do factoring videos later on where the leading coefficient is not 1, you must take the long way to factor this. The shortcut way will not work. All right, let's do a second question. Here we ask, is there a GCF? This is really the first important question to ask whenever you see a question that says factor completely. Is there a GCF? And in this case, yes, there is. All right, and we can see that GCF is 2. So when I take 2 out, what are we going to be left with? X squared plus x minus 30, right? And I would suggest that, off to the side somewhere, you go ahead and factor this. Maybe, over here to the right or some scrap piece of paper, go ahead and factor this, so things are not jumbled together. All right, so if I rewrite this and factor it over here, I'm multiplying 1 and negative 30, I get negative 30. I say, what two numbers multiply to get negative 30 and add up to 1? Right, we can see that 15 and negative 2 gives negative 30. But 15 and negative 2 won't add up to 1, you see. 10 and negative 3 give negative 30. But again, that will not add up to 1. The only two numbers that will work are 6 and negative 5. All right, 6 times negative 5, negative 30. 6 plus negative 5 is positive 1. So we've satisfied the condition, and if we take our shortcut approach, which we can because the coefficient is 1 here, so we could take our quick approach to factor this, which is just to say x plus 6 and x minus 5, right? So the final answer here is going to be 2 x plus 6, x minus 5. And we could have taken the long way to do this problem also, right? And the long way is definitely going to be needed when you work with a coefficient that is not 1. All right, moving on to some other questions. Number 3 here. Continue. See, the purpose of doing many questions is you get into a thought process that enables you to work the problems much more efficiently and with less error. All right, so here I say, okay, is there a GCF? In this case, no, right? And then we say, okay, is there, can I apply AC method? Let's try it. There are 3 terms, so I'll multiply 1 times negative 27, I get negative 27. Are there any two numbers that multiply to give negative 27 and add up to give negative 6? See, it might take a long time to figure this out. But just be patient and see if there are 2 terms. Don't be quick. If you find that you find no terms that work or no factors that work, it may not mean that there are no factors. So just be patient and try to exhaust all possibilities. So let's see, this is 9 and 3 will work. And one of these has to be negative. How about the negative 9? So negative 9 and 3. This multiplies to give negative 27, and it adds up to give negative 6. So these are the two factors that work. All right, this time let's take the long method to factor this. So for the long method, we just rewrite the first term, rewrite the last term, give a lot of space in the middle, replace the middle, replace the negative 6y by the two factors here. So and it doesn't matter the order. So if I put the 3y here, and I could put the negative 9y here, right? And then we just go ahead and factor by grouping. So if I group these two together, what can come out of this first group? Y can come out, leaving us a y plus 3. What can come out of this second group? A negative 9, leaving us a y plus 3. And then if you're not really sure that that's true, go ahead and multiply it back. So negative 9y is negative 9y. Negative 9 times positive 3 is negative 27. So we know we factored this part correctly. We could check this one also. Now that we see y plus 3 in both terms, we go ahead and factor that piece out, and we'll be left with y minus 9, right? So this sum factors to this product, all right? And if we took the shortcut approach, it's done in a flash, because the answer is just going to pop out as y minus 9, y plus 3. Finished. All right, and now let's look at number 4. For number 4, is there a GCF? No. Next, there's 3 terms. Let's go ahead and try the AC method. So AC method says 1 times 9. So I need to multiply to give 9. Find 2 numbers that give 9, and find those same 2 numbers have to add up to negative 4. Are there any numbers that will do that will satisfy these conditions? 3 times 3 will give 9, but that won't add up to negative 4. 9 times 1 will give 9, but those numbers will not add up to negative 4. It looks like there's no numbers that will work. So this trinomial cannot be factored, right? And when a trinomial cannot be factored, it's said to be prime. Okay. All right, moving on to number 5. Sometime you will see 2 variables in a trinomial, like how it's given here in number 5. Just take your time. So here, when we factor, as we did in the earlier problem, we're going to put, like here in this number 3 here, we had y there, right? But when we factor this one, or find the 2 factors, we're going to put uv instead, okay? And let's go ahead and do it. All right, so here we're going to use AC method again, but this time the coefficient here is 1. This coefficient here is 50, right? So 1 times 50 is giving us 50, but first let's ask, is there a GCF, right? So in this case, no. All right, next, we're going to apply that AC method. So we're looking for 2 numbers that multiply to give 50 and add up to give negative 15. Let's see. 5 and 10 works. But both of these numbers have to be negative. Right, so we found it immediately. So our shortcut approach would just be to say u minus 5v, and I have to put the v there, and u minus 10v. Right, that would be our shortcut answer. If we took the long approach, in the long approach, which is necessary in some cases, we'd rewrite the first, we'd rewrite the last term, replace the middle term by these two factors using uv, right? So let's go ahead and do that. So minus 5 uv minus 10 uv, right? And then factor from the first two, factor from the last two. What can factor from the first two? We see that u is common. So when I factor u out of these two, I get left over u minus 5v. And what's common in these two factors or two terms? We can see that a negative 10v. When you take negative 10v out of these two terms, you're going to have left u minus 5v, right? So we got u minus 5v in both terms. So that can factor out. Take u minus 5v out, we're left with u minus 10v, which is the same thing as what we had found in our shortcut approach. All right, so whether you use the long or short, you'll get the same answer. The short only works when the coefficient is 1. All right, let's look at the last problem here. Our thought process is, they ask us to factor completely. We say, is there a GCF first? In this case, yes. All right, so since there's a GCF, we need to factor that out first. So what is common in each of these three terms? We can see that it is negative 5. When you take negative 5 out of all three terms, you're going to have left over x squared plus 4x minus 5, right? And now your thing is to factor this piece, right? And I would do it off to the side somewhere. So what is x squared plus 4x minus 5? How does this factor, or can it factor? So we need to use the AC method. So let's say we need to multiply two numbers, see if they give us negative 5, and see if those same two will add up to positive 4. And we can see that 5 and negative 1 will work. So immediately this thing factors like x plus 5, x minus 1, right? And so our final answer, just using the shortcut approach here, don't forget to rewrite your GCF. It's a common mistake people make, including myself. Rewrite the GCF and then also rewrite the other factors that you found when you use the AC method. All right, I hope you found this video to be helpful. If so, like and subscribe. What we did here, this was the math of numbers and symbols, but we like to look at math as order in the broadest sense.